Hello everyone, for this tutorial video I would like to discuss iterated integrals, which are integrals, and sometimes integrals of that, etc. But since we learned double integrals in the last video, I would just like to stick to two iterations. In particular, we remember from the last video on double integrals that we assumed that the function is bound by a rectangle with points a, b and c, d. So it should follow that we can rewrite this integral as the integral from a to b and the integral from c to d of the function with respect to change in both variables at the same time, so change in y and change in x. And we can actually rearrange the order of the integrals and get the same exact value, which might make intuitive sense if you know how when you get a rectangle, it doesn't matter what order the length and width are in, you get the same area. So it should follow that the integral on the inside can have parentheses written around it to highlight how it is a single variable integral, which we know how to do from Calculus 1. So we compute the inner integral first, and then we compute the outer integral after we are finished with that. For example, if we want to compute this integral over the region specified, we would first write out the points in the limit of integration. Then rewrite change in area as change in y times change in x. We compute the integral of y first, simplify it, and then compute the integral of that, which has now been condensed into a single variable integral as well. And we get a finite value of 84. If we switch the order we do the integrals in, we should get 84 as well, because we are having the same region and the same function integrated over the same region. We confirm this is accurate using the same thought process as the first time around, and we get 84 again. Now that we've figured out techniques for computing specific values of multi-dimensional integrals, we can discuss applications of double integrals for regions that are not perfect rectangles, similar to what we saw in Calculus 1 when we studied curves that could not be approximated using perfect rectangles. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.